Starting soon. All right, and there's the recording. Hello, Dan. Cheers.
Hey.
I've got my, I don't know if you can see very good. He's a hedgehog.
Very nice. I've got the globe.
Worldwide, just like Kaggle.
Worldwide.
And Pitbull, I guess. He's a singer. So, for those of you who are...
How old do you think I am?
I don't know. Sometimes I'll say something about the internet and you'll be like,
Internet.
I don't know what music you listen to either, so.
I don't listen to Pitbull, but I'm aware of him. And I'm aware of the internet.
I'm sure you're aware of the internet, but I think we live in like slightly different corners sometimes. So for people who don't know who you are, this is Dan Becker, who you may be familiar with from Learn, which is your, I think of it as your baby. Would you call Learn your baby?
I think there was a period when it was. We now have other people who are producing most of the content, and I'm working on some other stuff as well.
Mm-hmm.
So, yeah, it's not totally my baby, but at one point it was. That's not good, actually.
Well, I mean, like kids grow up, right?
It's growing up.
Yeah, becoming a more, well-rounded platform, and
Yeah.
So we don't have to talk only about Learn, but what's different with Learn? If somebody hasn't been on the site in a while, what would they be surprised by?
Certainly so one of the things that I think is different between Learn and most other platforms in general is that because we produce the content, we can make changes in a way that doesn't require someone else to come in and make edits. And so I think the biggest difference is that stuff is just getting more polished every single day. And so we have new courses. The last one we released is probably my favorite that we have produced so far. It's intermediate machine learning.
Oh, yeah.
Alexis Cook put it together. She does an awesome job, makes these exercises that are like super fun and super hands-on and super interesting. And so we do have new material. We have a new feature engineering course coming out soon.
Oh, fantastic.
But the thing that I think makes me most proud is that stuff just gets better day after day in very subtle ways. So that it's not the one thing that suddenly lands as much as it's just better explanations each day and better feedback on users' code and yeah.
Sounds like some of that continuous integration and deployment I hear so much about.
Yeah, in a teaching sense, I think that's probably right.
Really? So I think people are always interested to hear, and I'm always interested to hear how people got into data science. So what's your background? How did you get into the field?
Yeah. So I listened to this podcast, Twimmel AI. And the thing I've observed is that every time he asks a guest like how they got into the field, they're always like, "Oh, I had this long and winding path," and then they'll start into it and they'll be like, "So I got a PhD in physics, and then towards the end, my advisor wanted to do something like deep learning applied to optics, and so I started doing deep learning, and then I got hired by Google." I'm like, that doesn't seem very wind and long. Like that seems like actually sort of standard. I think arguably I have a more unusual path. I mean, when I first finished, so actually before I finished college, I got suspended for a prank I played my senior year in college, my senior winter. And I...
What did you do? Sorry, going back, what was the prank?
So I went to school at Dartmouth College. I went to college at Dartmouth College. There is a tradition that every year the upperclassmen try and get the freshmen to run across the football field at a homecoming football game, which seems like a harmless prank or a harmless thing for people to do. One year, some people got hurt doing that, and the administration said, "Okay, we're done with this." And yet every year afterward, there's a cat and mouse game where the upperclassmen try and either peer pressure or in some way convince the freshmen to do it. And the administration says, "No, don't do it." I sent an email to all members of the freshman class that was spoofed. So it looked like it came from the freshman dean. This was the night before the event. And it said that because this was a tradition, it was no longer prohibited and that it was going to be fine. And you were not supposed to do that. And especially, I think that if you send something that looks like it comes from a student, the administration is like, we really would like for you not to do that. But with it coming from a dean, it's not good.
To be miffed.
Yeah. So
you're suspended.
So I was suspended, and I needed to get a job on short notice because, I found out I would be suspended a couple of weeks before the end of that semester, but before the oncoming semester. Actually, my first job that I got was as a mascot at the Canyon ski area. So depending on the day, I would either wear a bear costume or a moose costume. The bear costume being much better because the antlers of a moose costume make it very hard to ski. And then while I was in Utah, I got a job for a little internet startup, and they were trying to use neural networks. This was in 99 going into 2000. And so neural networks at the time were maybe in their first run through where people thought they might have potential, but they didn't really work yet. And so I got a job for a startup that was trying to use neural networks to tell online retailers how to craft their listings on eBay in a way that would make them sell better. That was a total and complete failure. And I decided that machine learning was a type of thing that sounded cool in a sci-fi book, but it would never catch on. It was just a total dead end. And that the thing that was actually useful was just descriptive statistics, very, very simple models, plotting data. I thought that was the only thing that ever had any real future. And I was in general because being part of a startup and I was the fourth employee, so being part of a startup that fails was a little bit of a difficult experience. Took some time off, worked for a rafting company in Ecuador. While I was in Ecuador, there was a time when Ecuador was undergoing very quick economic change. I decided to put together my interest in seeing a developing country together with my views about statistics and data. Went to graduate school in economics to study the economics of developing countries, or developmental economics. Got a PhD focused primarily on something called structural econometrics, which is, broadly speaking, trying to incorporate very rich knowledge or beliefs about how the world works into your statistical models in a way that has not caught on. That set of techniques, because of the amount of assumptions that you put in, which are just based on your beliefs about the world, has not caught on outside econometrics, or even within the field of economics. Is still a very niche way of doing things. So I got a PhD using structural econometrics, worked for the Federal Trade Commission for a couple of years, which is part of the US government. The US government had a shutdown in 2009 because all the politicians couldn't agree with each other about how to fund the government. I started competing in a Kaggle competition during that shutdown. And at first I came out of this and had all these beliefs that I formed in 2000, so they were outdated. They're reinforced by going to graduate school in a world that was very focused on classical statistics. Started competing and was if there were 1,500 people when I started competing, I was probably in 1,400 or 1,450th place. So not last place, but definitely in the bottom 10%. Was so surprised because I had such a high opinion of myself at the time that it was sort of a wake-up call of okay, I don't know how to, everyone else knows things that I don't know, and started just spending nights and weekends and every waking moment in this competition, and gradually rose up and started doing much better. Got into second place, was hired by an analyst consulting company to basically have their consultants that were working for large companies make the same transition that I made over the course of that competition and start using more modern machine learning. I think for people who are not doing data science as a career yet, they probably don't realize how good a background you get from analyst consulting by seeing so many different organizations and how each of them uses data science in real applications. So I did that for a few years. Worked for a company called Data Robot, which is like an auto ML tool.
I didn't know you worked for Data Robot.
Yeah, I was on the product. I was the product director there when they were about probably 20% the size of what they are now. I was employee 80 there. So I worked for Data Robot for a couple of years, then came to Kaggle.
Cool. Yeah, and what are you doing now? So it's you're still working on Learn, but what's in your scope?
Yeah, so I am primarily doing Learn, for which I really am just trying to influence the team, which is Matt and Alexis, who do awesome stuff.
Really?
And so they are really putting together the content and doing, I think, a better job than I did when I was putting together more content. But I am trying to influence them and make sure that the content they put together is really focused on applications, cuts out a bunch of stuff that is frequently taught because of the field's academic background, some stuff that, in working with a bunch of companies, I've observed no one uses this stuff in practice, with the goal of people being able to do independent projects very quickly. So I'm trying to influence them in that direction. I am working with the kernels team, trying to influence kernels in a way that, so kernels are Kaggle's notebook solution is kind of interesting. Most people probably think of us as a notebook in the cloud, one that doesn't charge you and gives you a bunch of compute. There are other notebooks in the cloud. Some of them, like Colab, are also very good, also don't charge you. One of the things that I think is different about Kaggle versus other companies that either build free notebooks or build notebooks you might charge for is that we have this huge community. Almost everyone is trying to get better at data science. And so the challenge is, how do we make this software facilitate interactions where users can learn from each other and make each other better?
Yeah.
Because I know that if I show you my research or a project that I worked on, you'll give me feedback. That will make my project better. That will make me better as a data scientist. And if we have a bunch of back and forth, I'm hopeful that something that you'll come out with a new insight, or even just explaining something to me is a super valuable way to improve as a data scientist and become better at explanation. So even if you just become better because you explained something to me, you still became better. And so the question is, how can we take this software where currently most people are sort of working in isolation and build features so that everyone has this feedback loop where they're all just making each other better, so that, ideally, in some ways it's very similar to Learn, of we're just trying to make the world really efficient by having a ton of good data scientists. And now it's how do we make them each make each other better?
Yeah, well, there's so many opportunities for cross-pollination as well. And, what are people doing in your field? Oh, that's cool. I've never seen that. Or I definitely, a lot of my friends in data science feel a little bit lonely. They're the only person who does what they do on their team, or they're the only data scientist in a small company, and not having that, I think it's pretty rare to be the only software engineer in a company. You usually have colleagues that you can chit chat with. So being able to provide that same experience for, people in our field is nice.
And data science is such a broad field that even if you're working with other data scientists, sometimes you'll say I'm going to do a certain type of project that I haven't done before. And it's really nice if you can benefit from other people in the world who are either good at that already or doing that and want to learn together.
Yeah, definitely. So speaking of learning, is there anything that you've learned about recently that you've just been really excited by? Blog post or tool or technique?
I have, and this is calling back a little bit to some of the approaches that I took doing structural econometrics. I've become really, really excited about probabilistic programming recently. So the big probabilistic programming languages are like historically it's been Stan, which is primarily in the R community.
I get
Within very good. In the Python community, I think the big one right now is arguably PyMC3. PyMC4 is going to be coming out soon.
Oh, okay.
PyMC4 is based on TensorFlow, and so is going to have all sorts of, like if you want to run stuff on clusters of GPUs or TPUs, that will soon be possible. Pyro is one which is based on PyTorch. But broadly, it's the idea of, I think the world is a really, really complex place. We frequently, with machine learning, say, I want to predict one thing, and it's a function of some other things. And I am not going to think about all the different ways that interacts with other equations. The thing I might want to predict is actually then an input in other things I might care about in reality. And so I think that it is really, really important for us to be able to estimate a lot of equations simultaneously in ways that captures the interactions between them, in ways where something that's is the dependent variable and one can be an independent variable in the other. And then that also facilitates what I'll call decision making. So frequently we have this machine learning model, it makes predictions, and then you say, okay, I've got this prediction, well, like, what should I do with it? So an example is a friend of mine works for United Airlines. I think he doesn't want me to talk too much about what they do, but one thing you can imagine every airline does is they need to set prices each day. So they're going to predict, for this flight, I've got 200 tickets remaining. It takes off in 100 days. I built this machine learning model that predicts I can sell.
No? Okay, sorry. I thought it was
Yeah, so I can sell like 3 tickets for $250 or 2 tickets for $300 today. Which of those should I do? And it's like, I don't know, there's this dynamic optimization problem, which is quite hard. And if you're saying, if you restrict yourself to think about one equation at a time, like we do for 99% of machine learning models today, then it's really hard to make good decisions and optimize decisions in any rigorous way. I think that optimizing that we make decisions based on the output of a predictive model probably has the potential for just as large a gain to the world in terms of efficiency as what we got when we went from like very simple statistical models to machine learning. And it's something that is on very, very few people's radar. But probabilistic programming languages have become much better. They're a really great tool for this. So that is the one thing that I am like hugely, hugely excited for right now.
Are we going to get a learn course?
Yeah. We've had this on the back burner for a bit. I've sort of been waiting for PyMC4 to be released. I'm not super close with the people who are working on it. From the outside, it looks like it's not coming on quite as quickly as I thought it might. So we might release something even before PyMC4 comes out, probably using PyMC3. But we will definitely have a learn course. And for what it's worth, I'm talking to a bunch of internal teams at Google, where hopefully we'll get to show internally how this is useful for a bunch of stuff. But I think the real impact is when the world of logistics is like 10% more efficient, and as a result, we're burning less fuel and emitting less carbon because we're making really good decisions, and the world is more efficient because everyone is doing this optimization in a really efficient and rigorous way.
Yeah. So in terms of compute costs, so you said that the MC4 is going to be built on TensorFlow. How does probabilistic programming compare with things like just really big neural networks?
So there are a couple of the answer is a little bit subtle. So probabilistic programming, many people won't know by that name, but it is a form of Bayesian estimation. And so you estimate your model, then you've got this whole posterior, which instead of just being a point where you give me some data, I make a prediction, I can also say, here's the likelihood. Instead of saying it's definitely going to be 7 or that predict's going to be 7, I can say, how likely is it to be 5? How likely is it to be 6? How likely is it to be 7, 8, 9, and so on? So you can fit the models with reasonable amounts of compute inference or predict, I may not call it inference because inference means different things in different communities, but prediction, if you want to predict that whole posterior, can be quite computationally inefficient. There have also been a couple of developments, the big one being variational inference, that makes basically the fitting of the model much, much faster by a factor of, I don't know, 10 or 50 over MCMC, which is the approach that has historically been taken. Variational inference in some ways uses a lot of ideas from deep learning where it can be driven by gradient. It has some shortcomings too compared to MCMC, but is way, way faster.
Yeah, because there's no guarantee that it's going to be convex, similar to neural networks.
Yeah, and you need, even more concerning than that is you need to make an assumption about the family that the posterior distribution is going to be in. And that assumption is, I mean, you can make a somewhat flexible assumption, so you don't need to assume it's normal. It could be some, gamma distribution or something that's pretty flexible, but it is some assumption. All assumptions are wrong. So yeah, MCMC allows you to not make that type of assumption and to have a posterior distribution that can have any sort of totally wild statistical distribution.
Cool, interesting. So before we wrap up, because we're going to lose our room soonish, is there anything that you want to share with the Kaggle community? Any tips or tricks or things coming up that you think people might like to know? This will go up next Monday, I think.
I'm gonna make the same sales pitch that I make on every at every opportunity. I think that doing hands-on work is fundamentally unlike doing courses. So you should take some of our Learn courses, despite the person who originally created Learn. I think our courses are better in the sense that they're shorter and they move you to doing stuff independently. But I really hope that people find topics that are of interest to them in the world, and that can be romance novels or sports or whatever. But find things that people find interesting. Find data, which we have over 10,000 data sets. Do something interesting. Send me a link to your interesting project. I love seeing interesting stuff. I love, send it to others in the community. I think that it's a real lost opportunity that we don't see as many people who just say, here's a topic I'm interested in, and I'm going to talk to other people who are interested in that topic about that data on Kaggle.
Yeah, more, communities of practice within the larger data science world. I agree. All right. Well, thank you very much for making time to talk with me today. I had a lot of fun. I learned a lot. Apparently, I can't trust emails anymore from you specifically.
You can trust the emails from me. It's the emails that look like they're not from me.
Unless someone is spoofing you. Anyway, thank you for joining, and I'll see you around, and everyone else can see you on Kaggle.
All right, sounds great. See ya.